Okay, so here is another example of a rational function. As I always say, just plug in the numbers first. So we have 1 minus 0 squared over 0 squared. So that's 1 over 0. The minute you see a 0 in the denominator, a non-zero number in the numerator, you know that there is an asymptote. Now, in order to find the limit as x approaches 0, and you know there's an asymptote, you need to find two different limits. One as we approach 0 from the left, and one as we approach 0 from the right. So that's 1 minus x squared over x squared. So 0 from the left and 0 from the right. So we have okay. So now let's look at this. Remember that if it's an asymptote, we know it's an infinity. We just need to decide whether it's a positive or a negative. How do we do this? If we're approaching 0 from the left, look for a number to the left of 0. Let's say a point, I don't know, 0, 1. Negative 0.01. So we look at a number to the left of 0. So it has to be negative. So negative 0.01 and plug it in. So we have 1 minus 0.01 the whole squared divided by negative 0.01 the whole squared. So in the numerator we have a positive, in the denominator we have a positive. So we know it's going to be a positive infinity. Remember that we plugged in the number only to determine the sign of the infinity. Now let's look at the other side of 0. We're approaching 0 from the right. So if that's 0, we're approaching 0 from the right. So think of a number close to 0, but to the right of 0. Let's say positive 0.01. So 1 minus positive 0.01 the whole squared divided by 0.01 the whole squared. So the numerator is positive, the denominator is positive, so therefore we have a positive infinity. Remember, we already know it's an infinity, we're just trying to find the sign of the infinity. Now remember, we were supposed to find the limit of 1 minus x squared divided by x squared as x approaches 0. So as x approaches 0, if we know it's an asymptote, we have to find the left limit and we have to find the right limit. Each is equal to a positive infinity. Note that this is equal to this. The left limit is equal to the right limit, and hence we can write the limit as positive infinity. So this function has an infinite limit as x approaches 0. Let's look at the next one. First of all, plug in the 2. Limit as x approaches 2 from the right. Whether we are approaching from the right or the left, the first thing we need to do is plug the number in. So when we plug the number in, we get a 2 over 0. This is when we know it's an asymptote. Remember, like we discussed before, it's an infinity if it's an asymptote. The only thing to determine is whether it's a plus or a minus. Plug in the number to the right of 2, which means greater than 2 but close to 2. So if we plug that in, we get 2 over 2.01 the whole squared minus 4. The numerator is positive anyway. The denominator is also positive because when we square 2, we get a 4. If we're squaring something slightly greater than 2, we get something slightly greater than 4. So that would be positive. So therefore, as we approach x from the right, we have positive infinity. Now what if we're approaching x, or as we're approaching 2 from the left? We do the exact same thing. We know it's some sort of infinity. Plug in the 2, or plug in a number close to 2 but to the left of 2, and that could possibly be a 1.9 the whole squared. Now the numerator is positive, the denominator is negative, because 1.9 whole squared would have to be less than 2 squared, which is a 4. So that would be a negative, and in effect that would be a negative infinity. So from the right, it's a positive infinity. As we approach 2 from the left, it's a negative infinity. So in general, the limit 2 over x squared minus 4 as x approaches 2 does not exist.